A body starts from rest, so u is equal to 0 with a uniform acceleration of 2 meter per second square. So 2 meter per second square. Find the distance covered in time equal to 2 seconds. So again, there are three equations of motion. S we want, so S is equal to ut plus half at squared. So that is 0 into 2 plus half into 2 into 2 squared. So this 2 will get cancelled. So this will be 0 plus 4. That will be 4 meters. Okay. The second question over here, a body starts with an initial velocity of 10 meter per second. So that means u is 10 meter per second and acceleration is 5 meter per second squared. Find the distance covered. Okay, so distance covered in 5 seconds. Again, we use S is equal to ut plus half at squared. So this is t into 5 plus half into 5 into 5 into 5. Okay, so in this case, what we do is this will give us 50 and this will give us 125 over 2. So that will be 50 plus 62.5, and so that will be 112.5 meters will be the distance. Okay, so remember that there are three equations of motion. V is equal to u plus at, which can be written as a is equal to v minus u over t. And we have s is equal to ut plus half at squared, and v square is equal to u square plus 2as. So only three equations are there, and reading the question you should learn to pick up what is given to you, and so you will be able to choose a equation and get the answer. Okay, moving ahead in this is the next question we have. So let's see what is given. A vehicle is accelerating on a straight road. Its velocity at any instant is 30 kilometer per hour. So if I call it as u, 30 kilometers per hour, so that will be 30 into 5 by 18, 6 threes are 6 fives are, so that is 25 upon 3 meter per second. And after 2 seconds, the velocity will become 33.6 kilometer per hour. So this will be 33.6 into 5 over 18. So 6 threes are, and this will be 5.6. So that will be 28 over 3 meter per second. And the time given is 2 seconds. So let's find the acceleration. Again, I'm using the formula a is equal to v minus u over t. So this is 28 over 3 minus 25 over 3 over 2. So if you solve this, you get 3 into 2 and 28 minus 25. So this comes to 0.5 meter per second square as an acceleration. Now this is only the first half. Okay, so that is from here to here. And now if you read the question, it says that in further 2 seconds, the velocity becomes 37.2. That means now if you take the velocity initial as 33.6 kilometer per hour, which we know it is 28 upon 3 meter per second, and you take the final velocity as 37.2 kilometer per hour, which will become 37.2 into 5 over 18. 6 threes are 6.2. So this will be 31 over 3 meter per second. Now again over here the time is given to be 2 seconds. So if you find acceleration, that is v minus u over t, that is 31 over 3 minus 28 over 3 upon 2. So 31 minus 28, 3 over 2. So this also comes to be 0.5 meter per second square. So both times you get the same answer. So the answer is find the acceleration of the vehicle. So we got it as 0.5. And is the acceleration uniform? So yes. Why it is called as uniform? Uniform means something that remains unchanged, and that is remaining unchanged over here. Okay, do you have any questions, anyone?
So I have a question.
Yeah.
So over here, like the values are given in kilometer per hour only. Then why can't we work with them in kilometer per hour?
Yeah, that's not a problem. But here, then you will need to specify the unit. Okay, because you will be subtracting something like 33.6 minus 30 over 2. So your numerator is kilometer per hour and your denominator is in seconds. So what will you write? 3.6 over 2, that will give you 1.8. But what will be the unit? Are you understanding that? 1.8 what?
So we can't convert second to hour and then right?
No, that's up to you, right? So unless you are doing it, you should be writing some unit, right? So you need to convert that.
Okay, sir.
Yeah. So like in this particular case, it will be kilometer per hour upon seconds. So if it is 1.8 kilometers, now if you multiply by 1000, you will get meters, and this is hours into seconds. So that will be 3600. Then it will become second square, and this will be 20. So you get 1 by 2, which is same. Okay. So unless means ultimately you will have to convert it to get a common unit. Fine. Question number 5 now. So in question number 5 over here, let me write a bullet initially moving with a velocity 20 meter per second. So u is equal to 20 meter per second, strikes a target and comes to rest. So that means v is equal to 0 and penetrates a distance of 10 centimeters. So s is equal to 10 centimeter, which will be 10 over 100, which will be 0.1 meter. Okay, now you have to calculate the retardation cause. So now here you need A. Okay, so just for your reference, I will write S is equal to UT plus half AT square, and V square is equal to U square plus 2AS. Now we will not use the formula because T is not given to us, so we will have to use the second one. So let's write V square is equal to U square plus 2AS. Now in this we have 0, and this will be 20 squared plus 2 into A into 0.1. So this I will write it as negative 400, and this will be 0.2A. So negative 400 upon 0.2. So what will we get if you shift a decimal?
So 2000 minus
Yeah,
2000.
yeah, 2000 meter per second squared. Now, since they are asking for retardation, so we will write, therefore, retardation is 2000 meter per second square. Do you follow that? Okay, so when they are talking about retardation, we don't write negative. Okay,
So,
yeah.
so over here, they are not said that how much distance the bullet has traveled first. Then Like over there, if it has reduced its velocity by like 0.1 meter per second, then how do we know that difference and like that?
No, it says that the bullet was traveling with that velocity. Like suppose this is a bullet, it was traveling with 20 meter per second and it strikes a target. Okay, so the moment it hit the target, the initial velocity was 20 meter per second. Then it says that the bullet penetrates 10 centimeter before it stops. It says that it strikes the target, comes to rest after penetrating a distance of 10 centimeter. That means we know that the initial velocity to be 20, and when it comes to rest, final velocity to be 0, and in between that the distance covered is 10 centimeters. Okay, do you have any confusion with that?
No, sir.
Okay, now moving ahead, what we have is question number 6. So a train moving with a velocity 20 meter per second, so u is equal to 20 meter per second, and it is brought to rest, so v is equal to 0 by applying brakes in 5 seconds. So t is equal to 5 seconds. So again, this is pretty easy. A is question mark. So A is V upon, so that will be 0 minus 20 upon 5. That will be minus 4 meter per second square. And they are talking about retardation. So that will be 4 meter per second square. Okay, this is T. So 100 over 20. So we get T as 5 seconds. So we got some more information now, okay, just by using the information that was given to us. Okay, now what we have to use is uh, we need U and you need A, okay, with the information given to us. So let us solve this. So the first thing that is there is S is equal to UT plus half AT squared. Now in this, if you plug in, what values do you get? S is equal to 100 and U we don't know, okay? And the other formula that we have is V square is equal to U square plus 2AS. So here you have 25 squared is equal to U squared plus 2 into A into 100. So that is 625 is equal to U square plus 200 into A. So this is also leaving us with two variables. Okay. Another formula that we have is, V is equal to U plus AT. So 25 is equal to U plus, just a minute, U plus A into 5. Okay. So let me write down that U plus 5A is 25. This is 1. And what other formula we have? The top one, S is equal to UT plus half AT square. So 100 is equal to U into phi plus half into A into phi squared. So if you reduce it, say you divide by phi, so you get 20 is equal to U plus 5A over 2. Now this can be written as 2U plus 5A equal to 40. So now what has happened is you have got two equations. One is this and one is this. And you can use them simultaneously to get the answer for U and A. Okay. So this is 2U plus 5a is 40, and if I multiply this by 2, I get 2u plus 10a equal to 50. And if I subtract them, I get minus 5a as minus 10. So a is equal to 2.
2.
Okay, and if I plug a as 2 over here, so 5 into 2 equal to 25. So u is equal to 15 meter per second.
So
Okay, yeah.
the over here, can we also use the equation we got from v square equals to u square plus 2as?
Yeah, so here like you got this one, so that also can be used. But since there was a power of u square, okay, that can't be used to solve simultaneously. One thing you could have done is substituted the value of u in that, okay, but that will give you a quadratic. Again, you will have to